Hello students, happy morning. Class 12 Physics, Unit 2, Current Electricity Revision Continuation video. In our previous class, we discussed the book back question from two subtopics that are electric current and Ohm's law. Here some more questions are pending in Ohm's law. Let me see by today. First question, that is question number 2 in long answer. That is explain the equivalent resistance of a series and a parallel resistor network. Okay, this type of question we already seen in unit 1, that is find the effective capacitance of series and parallel network. Okay, whatever the idea we used in that question, here also we are using the same idea. Okay, that are we know very well. In a series connection the charge is same, in parallel connection the potential difference is same. Okay, we have to use the same scenario. Okay, first one, that is resistor in series. Here I consider a resistance of resistor R1, R2, R3. Okay, here I can say three resistor of resistance R1, R2, R3 are connected in series, that is 1 to 1. Okay, then the free ends of the circuit is connected with a battery of potential difference V. Okay, here we know this is a series connection, so the charge flow across each resistor will be same. We know the flow of charge with respect to time is known as current, so the current is also same for each resistor. Okay, so it is indicated as I, here also I, here also I. Okay, then the applied potential is split up as V1, V2, V3, because we know each resistor having different resistance value, so the potential drop across each resistor will vary. The potential drop across R1 is V1, then R2 is V2, then R3 is V3. By applying the potential V, it is split up into V1, V2, V3, so we can sum it as the net potential V is equal to V1 plus V2 plus V3. Okay, see here in series current is same. Okay, then next I am applying Ohm's law. Okay, in first lesson we are applying C is equal to Q by V, or Q is equal to CV. Okay, here we are applying Ohm's law. We know V is equal to IR, so V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3. Okay, then this equation, these values are put into the equation V is equal to V1 plus V2 plus V3. Okay, then we get V is equal to, that is V became IRS. Okay, here RS is a equivalent resistance. Okay, this three resistance became a single resistor of the resistance value RS, that is V is equal to IRS. Then we know V1 is equal to IR1, V2 is IR2, V3 is equal to IR3. Okay, then solving this we get RS is equal to R1 plus R2 plus R3. Here this equation implies the equivalent resistance is the sum of the individual resistance. Okay, that's all. Always the equivalent resistance is greater than individual resistance. Okay, for this question let me see what are the important things. Okay, you need to know. First one, the question is resistor in series. For this we need to draw a diagram. Okay, having the resistor R1, R2, R3 that are connected in series. Okay, R1, R2, R3. Then the free ends, that means the free terminal is connected with a battery of potential difference V. After the connection there will be a flow of current I. Okay, this current is same in each resistor R1, R2, R3. Okay, but the value of the resistance is differ, so the potential drop across R1 is V1 and R2 is V2 and R3 is V3. Okay, here it is a series connection, current is constant, that means voltage, that is the charge flow across each resistor is constant, so current is constant. Current is constant. Okay, we know the net potential V is equal to V1 plus V2 plus V3. Okay, we know according to Ohm's law V is equal to IRS. Okay, then V1 is equal to I R1, V2 is equal to I R2, V3 is equal to I R3. Okay, substitute in this expression, then we get V is equal to V1 plus V2 plus V3. Okay, V became I Rs, V1 became I R1 plus I R2 plus I R3. Okay, on solving this we get Rs is equal to R1 plus R2 plus R3. Okay, here Rs is the effective or equivalent resistance of the resistors that are connected in series. Okay, always Rs is greater than R1 or R2 or R3. Okay, this expression can be stated as the equivalent resistance is equal to sum of the individual resistance when resistors are connected in series. Okay, always the effective resistance that are equivalent resistance Rs is greater than R1 or R2 or R3. If suppose n resistors that are connected in series, n resistor of same resistance in series, for that we can write Rs is equal to Nr. Okay, the next part, that is equivalent resistance of the parallel resistor network. Okay, here in parallel connection, okay, we know very well all the free terminal of the resistor that are connected to a same battery terminals. Okay, for this case the potential drop across each resistor will be same, but the current flowing across each resistor will be different because of different value of the resistance. Okay, here the current I is subdivided into I1, I2, I3. We can write I is equal to I1 plus I2 plus I3. We know Ohm's law, V is equal to IR, I is equal to V by R. So we can write I is equal to V by RP, but I1 is equal to V by R1 plus I2 is equal to V by R2 and I3 is equal to V by R3. Substituting in this expression, then we get V by RP is equal to V by R1 plus V by R2 plus V by R3. Okay, on substituting, on cancelling the value of V, we get 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, here this can be stated as in a parallel network. Okay, in a parallel network, the reciprocal of the effective resistance is equal to sum of the reciprocal of the individual resistance when the resistors are connected in parallel. Okay, always the RP is less than the individual resistance. Okay, for this question, what are the important things needed to answer the questions? Okay, resistors in parallel. First of all, we need to draw a diagram. Okay, having three resistors that are connected in parallel across the battery of potential difference V. Okay, here it is R1, R2, R3. By connecting this, there will be a current I. This current is put up as I1, I2, I3. Okay, so we can write here it is a parallel network, so the potential drop across each resistor will be same. Okay, potential drop across each resistor will be same. Okay, so the current I is equal to I1 plus I2 plus I3. We know very well I is equal to V by R. This is a one more form of Ohm's law. Then we can write I is equal to V by RP. Okay, and I1 is equal to V by R1, I2 is equal to V by R2, I3 is equal to V by R3. Okay, substituting this expression, then we get V by RP is equal to V by R1 plus V by R2 plus V by R3. Okay, on cancelling the potential difference on both sides of the equation, then we get 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, this equation shows when the resistors of different resistor different resistance that are connected in parallel, then the reciprocal of the effective resistance or the equivalent resistance, that is equal to sum of the reciprocal of the individual resistance. Okay, if n resistor of same resistance are connected in parallel, for this case we can write 1 by Rp is equal to n by R, then Rp is equal to R by n. Okay, always the value of Rp is less than R1 or R2 or R3. Okay, the effective resistance is always less than that of individual resistance. Okay, then our next subtopic, that is energy and power in an electrical circuit. Okay, let me move for the short answer question. First question, what is electric power and electric energy? Electric power, it is the rate of doing electric work, and electric energy, it is a capacity to do work. Okay,